recapping binary search then, your key thing, data must be in order. We call that a prerequisite. You may have seen the term prerequisite used for when you're trying to like install software and things. It'll say, in order for this to work, you need this installed first. Okay? Yeah, a prerequisite. If it isn't, you cannot use binary search. You start with a middle item, and we'll always truncate, but you could round up. I don't care which you do, but you must always do the same one. If the item you're looking for is at that middle position, stop, you found it. Well done, excellent. Go and have a Mars bar or something, if that's what you do. If it isn't the one we want, well, substitute your favourite food stuff. Doesn't have to be. You're distracting from the video now. Right, if the item we're looking for isn't the one, then we need to do a test. Are we bigger or smaller? So if the thing we're searching for is bigger, then we don't need to look at the left-hand side. And remember, the reason we don't is because the date is in order, and we know that every item is going to be smaller. So there's no point in looking. So we discard that left-hand side, and we physically do that by adding 1 to the left pointer. So it moves to the side of M. So we look at M, and we say add 1 to it. That's where we want the left to be. If we're smaller, then everything on the right of the thing we just looked at is going to be bigger, and there's no point in looking at those, so we discard the right. And we do that physically by saying move the right pointer 1 to the left of the middle pointer. So where we were just looking. What you don't do is you don't include the middle again, because that'll break it, because you've just looked at that position. There's no point. And the final stop for the list being exhausted is if the left pointer ends up bigger than the right pointer. So let's just look at that in a little example just to clarify that. So if I've got, I'll just do it with a few data items. So I've got like 5, 10, I'll make it easy for myself. I'll just do a series. Right, if I'm looking for 17, so left starts there, and I'm just going to do this super quick. Right, so the middle is there, first time. So hang on, let me move 17 out of the way. So I'm searching for 17. That's what we're looking for. Right, so we go, right, okay, it's not what we want. 17's bigger, so we're discarding this left-hand side. So that left becomes M plus 1. So it ends up there. So we search again. So we go 3 and 4, div 2, that gives me 3. So the middle ends up there. And we look at it and we go, right, 17. That's not what we want. Okay? 17 is smaller than 20. So we as humans go, oh, we've finished. But we can't do that. So we say, right, okay, we're going to discard the right-hand side of the list, because they're all bigger than 20. So 17 isn't going to be anywhere near those. So we move the right pointer to the left-hand side of M. So we say M minus 1. So the right pointer ends up there. So at this point, left is now bigger than R. So we're exhausted. We're fed up. We've exhausted the list. That is the stopping condition. So when we code this, that's one of the things we do to say stop searching now. So we say as long as left and right are in relatively the correct positions, then we're good to go, and we've got a list that we're searching. As soon as they flip, we say, whoa, stop. We've exhausted the list. Something's gone horribly wrong. Okay? So it's actually, again, it's a simple algorithm. It just involves a little bit of work. You can see there's like 3 or 4 steps involved every time we do a search. With a linear, simple. Just say, is it the one? No, move on. Is it the one? Move on. Is it the one? Move on. That's super quick. Computers can do that sort of thing monstrously quick. This one's got some ifs in it. You know, is it bigger, smaller? Oh, we'll do that. Then we do a calculation. Then we do the middle calculation again. So with a short list, binary search is not your friend. With an unordered list, binary search is not your friend. But with a large, ordered list, binary search is your best buddy. Okay? So pivotal in all of computer science, binary search. Great algorithm. So easy, and it mimics what we do naturally as humans as well. So I like it from that point of view.